Hello students, today we are going to start our chapter 5 and name of the chapter is Continuity and Differentiability. Before we start with this chapter, I would advise you to revise your chapter of class 11. The chapter was chapter 13 and name of the chapter was Limits and Derivatives. If you have revised this chapter, then it will be easy for you to understand the concept of continuity and differentiability. I'm going to explain you about the continuity first. A function fx is said to be continuous at any point x is equal to c if left hand limit is equal to right hand limit is equal to f of c. Left hand limit, if you remember, we have done in our class 11, limit x approaches c minus f of x. Right hand limit is limit x approaches c plus f of x, and f of c is the value of the function fx at any point x is equal to c. If all these three are equal, we say function is continuous at that particular point. But if any of these three are not equal, that means function fx is discontinuous at that particular point. Right? Now remember one thing, constant function, any constant function, any polynomial function, and these two functions are continuous everywhere, but rational function, if you talk about, rational function is continuous in its domain only. Right? Now we are going to check if suppose the function is not defined in this way. For example, it is given x if x is less than 1 and 5 if x is greater than or equal to 1. That means we will say this function, we will be finding left hand limit and right hand limit, then value of the function at x is equal to 1. Since x is less than 1, that means this will be the function for left hand limit. When x is greater than 1, this will be the function for x when it is greater than 1, and for equal to 1, again this will be the function. So when you find out left hand limit, you will say limit x approaches 1 minus f of x, which will be limit h approaches 0 minus, here it was x, which will be replaced with 1 minus h. That will give you limit h approaches 0 minus 1 minus 0, which is equal to 1. Then you go for your right hand limit, which says limit x approaches 1 plus. This is the function for your right hand limit, which is equal to 5. And obviously for x is equal to 1, the function is again 5. Since all these three are giving you different values, then you will say function is discontinuous here. For example, if one function is given you in this way that fx is equal to 5x minus 3, and you need to check the continuity of the function at x is equal to 0, x is equal to minus 3, x is equal to 5 at these 3 points. Now you will see here that function is defined single here. That means you are not going to find out left hand limit or right hand limit. Here you will be finding only limit x approaching one number you are going to pick up. If x approaches to 0, we are checking the continuity at x is equal to 0. So limit x approaching 0, f of x, limit x approaching 0, 5x minus 3, which automatically will give you minus 3, and f of 0 is also minus 3. Hence these two are coming equal, so you will say since limit x approaching 0, f of x is equal to f of 0, which implies fx is continuous at x is equal to 0. Similarly, you can check for minus 3 and 5. Function will remain continuous at these 2 points also. Now comes your next question, which I would like to explain to you for the modulus one. Suppose the function, this example, if function fx is defined as x upon modulus of x if x is less than 0, minus 1 if x is greater than equal to 0, and you are going to check the continuity of the function. Remember one thing, if sometime point is not mentioned, suppose the point was mentioned here in this question and in the previous question also, but here point is not mentioned, then what you need to do, you will be observing here where the question is being defined, where the function is being defined. Here the function is defined for greater than 0, less than equal to 0. That means we are going to check the continuity for x is equal to 0. We are going to find out left hand limit first. So this will say limit x approaches 0 minus. Now if you observe for less than 0, this is the function. So it will be x upon modulus of x. Before I continue with the function, let me remind you what was the modulus function. It was minus x if x is less than 0, and it is x if x is greater than equal to 0. Since x is approaching 0 minus, from that means x is approaching to 0 from the left hand side. So this will become minus x. Limit x approaching 0 minus, it will become x upon minus x, which will give you minus 1. Now comes right hand limit. That says limit x approaches 0 plus x upon x, which is equal to 1. And if you go for f of 0, that is again minus 1. So these three values are not same. Hence you can conclude that fx is discontinuous at x is equal to 0. X is equal to 0, function is discontinuous. So this way you need to check the continuity and discontinuity of the question given in your exercise 5.1. I would like to explain one question which I hope is your question number 17, exercise 5.1 of NCERT. Here function is defined in this way: fx is equal to ax plus 1, x less than equal to 3, and bx plus 3 if x is greater than 3. It says that function is already given continuous at x is equal to 3, but you need to find the relation between a and b. You will start the question since fx is continuous at x is equal to 3, so your left hand limit is equal to right hand limit is equal to f of 3. Left hand limit we will find out. It will be limit x approaching 3 minus f of x. And here if you see function for less than equal to 3, that means for left hand limit the function is defined as ax plus 1. So it will become ax plus 1. So we are going to substitute x is equal to 3 minus h. As x approaches 3 minus, h will approach to 0 minus. Limit h approaches 0 minus a of 3 minus h plus 1, which in turn will give you 3a plus 1. Give it number 1. This is your left hand limit. Now come for your right hand limit. For your right hand limit, this is the function defined. So you are going to take it as limit x approaches 3 plus f of x, which in turn will give you limit h approaches 0 plus bx plus 3. Here x will be substituted as 3 plus h. So it will become 3b plus 3. So these are the two values, left hand limit and right hand limit, which is equal to f of 3. If you consider all these three as to be equal, we can easily find out the relation between the same. 3a plus 1 is equal to 3b plus 3 by the definition. Hence you will be getting the relation a is equal to b plus 2 by 3. So dear students, you are supposed to solve exercise 5.1 from your NCERT on the basis of the concept taught to you today. I am giving you 2 days, Monday and Tuesday, to complete this exercise, and you are supposed to revise differentiability basic concepts which you have already done in your class 11 derivatives of the various functions which I have already taught you. You will be revising all those so that I can start with the concept of differentiability on Wednesday. Stay safe, have a nice day, and keep on solving the questions at home. Thank you and have a nice day.